So it's basically Qtum and Mimblewimble, privacy tokens, privacy smart contract, privacy atomic swap, privacy stablecoin, privacy lightning network, and privacy wallet integration. Our judging panel includes 3 co-founders from Qtum, which is Patrick, Jordan, and Neil, and 3 core team members from Beam, including Alex, one of their advisor, and one of their ambassador. And we also have a core developer from Grin, which is another blockchain privacy project. So for the prizes, we'll have one first prize winner with a reward of $25,000 worth of Qtum tokens, one second prize winner with a reward of $15,000 worth of Qtum tokens, and one third prize winner with $8,000 worth of Beam tokens, and one fourth prize winner with $4,000 equivalent of Qtum tokens. So in addition to that, we also have 2 milestone prizes for a total of 4 weeks, starting from July 8th to August 8th. So it's top community and top update. For top community, we track the hashtags of Qtum 2019 Hackathon on all social media. So we will share this on a website and also on our Discord channel. And for top update, it would basically look at your GitHub to see how it's going on the coding. Both top community and top update would get $1,000 worth of either Qtum tokens or Beam tokens. We'll also finalize it and share it with us. And moving on to our key timelines, our registration started on June 19th and it will be open for a month till July 18th. So if you have other friends you want to invite, please go ahead, send them the link. And a final submission will start on August 11th, which means we'll have about roughly 2 months for development. And we'll have open the submission for a week and end on August 18th. So after the registration, you will find the link to our Trello, which is where we form teams. Do read the term of conditions and participant agreement after when you do the register. And the Trello to form teams is fairly easy. We have examples up there. Please check it out. One thing to notice that we allow a team from 1 to 5 members. So the maximum size for a team is 5 and the minimum is 1. And for the final submission, please note that we do have a fresh code policy, meaning that all participants may begin coding on June 19th after we kicked it off. And the code of all submission is required to be open source. For the final submission, your project needs to submit 2 to 3 minutes of video of the product demo. So lastly, our judging criteria is also published on our website, which is first, Qtum applicability. Is it reasonable to use Qtum? Is it used in an innovative way? Second is creativity, the degree of innovation of the product. And third is practicality. How practical technically is the project to use? And fourth one is technical. What is the technical difficulty of the project, and was it professionally executed? And the fifth one is influence. We do want the application to have a real, introduction. Next, I'll give the floor to Howard to give us a tech overview. Shunji, you might want to switch that to Howard.
I will ask the Alex to share first according to our schedule.
Oh, sorry. And then let's welcome the CTO of Beam, Alex, to give us a general introduction. Thank you for being here, Alex.
Hi, thank you very much for having me here. So I will start with a short overview of the current state of privacy technologies in cryptocurrency space. And right now I'm talking mostly about public blockchains, cryptocurrencies, not about general blockchain projects, because there are many different projects in terms of how the blockchain is structured and what consensus is used. So I'm talking about projects like Beam, like Monero, Green, Zcash, and similar general cryptocurrencies that right now have privacy features. So in general, this world is divided into two different directions in terms of technologies that are being used to achieve privacy. And these directions are zero knowledge proofs and basically all the rest. So when you want to create a practical private cryptocurrency, you need to be able to eliminate the ability to see who was the sender of the transaction, the receiver of the transaction, and the amount of the transaction itself. And each project achieves this in a different way. Like Zcash is using zero knowledge proofs to hide all this information. Monero has a combination of several technologies, such as ring signatures, confidential transactions, and shielded addresses or stealth addresses to be able to hide the receivers. Mimblewimble is a relative newcomer to this space. Two coins that have implemented this protocol were launched at the beginning of 2019, Beam and Green. And the idea itself was first published somewhere in the middle of 2016. And it takes a little bit different approach from all the existing technologies. It does not use zero knowledge proofs extensively. Instead, what it does is basically restructures the way the transaction is built or defined by using a very simple idea of using Pedersen commitment, which is basically a sum of two elliptic curve multiplications to create a UTXO. And in this structure, the UTXO is actually sum of two factors. The first factor being the value, which is encoded by one generator on this elliptic curve, and the other one is the so-called blinding factor, which has two purposes. One is to obfuscate the amount, and the second one is to prove the ownership of the UTXO. So there are basically two different uses for the same factor. And the sum of them, the commitment itself, is the UTXO that you can transfer from one user to another by simply changing the blinding factor. In order to validate that these transactions are actually valid and do not create any additional money out of thin air, each node is able to verify that the total sum of all inputs of these transactions and all outputs of these transactions actually sum to zero. And of course, to be able to do that, they need these differences in the blinding factors, because when the UTXO changes ownership, the blinding factors are obviously different. So this difference is encoded separately in what is called the transaction kernel. So basically the sum of all inputs and outputs in the kernels should be zero to make sure that no new money was created in these transactions. So this is the very high-level introduction of how Beam and Green are doing things using the Mimblewimble protocol, and I will obviously mostly focus on this technology. Even though there is a small use of zero-knowledge proofs in both projects, because each UTXO should be proved to be positive without disclosing its value. If I'm able to create a negative UTXO, I can actually use it to create new money out of nothing. So to prove that each UTXO has a positive value, each of them is actually added a small zero-knowledge proof. It's a zero-knowledge range proof that proves that the value is positive without disclosing the value itself. Both projects currently use the most efficient implementation on the market, which is bulletproofs created by Benedict Bunce. And this allows us to complete this structure. And I really recommend to read the original white paper of Mimblewimble, which could be found on our website, beam.mw, or generally on the internet, because it's very concise, it's very simple to understand, just 4 pages long, but it presents the original idea in its original form. Of course, it was published by anonymous author, which makes it even more mysterious. So this is the basic layer of what we're doing. I will talk 2 minutes about some additions, and then I will pass the mic to Howard. The basic Mimblewimble protocol actually just describes this idea of structuring UTXOs this way, and it explains how it allows it to achieve not just privacy, but also scalability. Because when we combine a lot of transactions together in a block, all the intermediate outputs are removed because it's a linear combination. So there's like plus factor and minus factor. If I transfer the UTXO ownership, they just cancel each other. And when I take this logic to encompass the entire blockchain, all the intermediate transactions are actually removed, and I'm only left with the current state of the blockchain and the series of blockchain headers that describe the history, and they allow me to prove the state at each block. So this results in a much, much smaller blockchain compared even to Bitcoin, not to mention Monero or Zcash, which actually make the blockchain even larger by adding additional encrypted information on top of it. So this is the basic Mimblewimble, but both projects have improved it in many different ways. And one of them is, for example, the addition of the Dandelion protocol that allows to basically interfere with the possible tracking of the UTXOs even by malicious attackers that listen on the blockchain. And during this Dandelion, the stem phase, and I will not go into details here, please read about this further, but the UTXOs are combined together. So basically each next node doesn't even know where these UTXOs originated or which transactions they belong to. And of course, in Mimblewimble, no addresses are recorded on blockchain at all, which is very, very different from what people are used to in Bitcoin and most other cryptocurrencies, where the address is the inherent part of the transaction. And having no addresses on the blockchain means the two wallets have to be online together or at least somehow communicate and interact in order to create each transaction, which has some drawbacks, but it also have a lot of benefits that we are using in Beam, such as, for example, being able to add additional agreed on and signed information to the transaction, and use these additional communications, as I will explain later in a more technical section, to be able to realize things like Lightning Network and similar mechanisms. So this is the introduction for now. Natalie?
Okay, I think maybe Natalie is not online. And after the introduction of the privacy, I believe you have another sharing about the challenge expansion. Do you have that? Hello, Alex. Wait a minute, Natalie.
Thank you, Alex, and thank you, Shenji. And so coming up, we have another, so I think coming up we have Howard to do an introduction for about a general tech overview of Qtum. Yeah, let's give the floor to Howard.
Hello. Can everyone see my screen? Let's see. Let's chat. Where's the chat? Okay. Okay, so it's working. All right. So I prepared this presentation to share like the ecosystem of privacy technologies and like all sorts of different experiments. So it's mostly to show what's possible on Qtum, and also to give like the community some ideas on what you could build for the hackathon. So it's just a very simple introduction about quantum. Like the technical architecture is divided into two layers. Underlying quantum is the transaction layer, which is how the money is transferred from one address to another. And on this layer, it's UTXO based. It's inherited from Bitcoin. So we have the same address and the same encryption model as Bitcoin. And on this layer, you could build functionalities using Bitcoin script. So like Lightning Network and like time locks, atomic swap, you can build these technologies on the transaction layer. And on top of the transaction layer, we build this account abstraction model, which allows us to provide account-based smart contract. And on this layer, you can build applications, like all sorts of privacy applications, zero knowledge applications using smart contract. And for these types of applications, this is compatible with Ethereum, and you will be using Solidity to build a smart contract. So this is a really very simple rundown of like the how-to of building on quantum. You can choose to either build on the transaction layer, or you can choose to build for the application layer. All right. So here are just some ideas about various privacy techniques you could use, and also projects and experiments on that you can build in the application layer. So like on the transaction layer, there are just like all kinds of different techniques you could do. Like CoinToeing is a very simple mixing technique. And in a way, Mimblewimble is also a kind of CoinToeing. And CoinToeing, I'll go into like more detail about how these things could be built and how you could build it for the hackathon. And then there's the problem of how to anonymously transmitting transaction. So one problem with privacy is even if the transaction itself is private, the way you transmit the way you transmit a transaction could be tracked just from your IP. So that's a problem. Then we have all kinds of like, for example, with Mimblewimble and being their standalone, which is a way to transmit transaction privately by gossiping. Then there's also, of course, confidential transactions, which could also be built on quantum, but yeah, it's something you could try. And on the application layer, we can support zero knowledge applications, and I'll expand into that in more details. And then there's also the interesting possibility of running your computations off-chain. And if the data is not on-chain, then you have the privacy of keeping your data off-chain instead of publishing everything on-chain. Okay, so we'll talk about like CoinToeing mixer, and this is essentially you could look at the Bitcoin ecosystem and find interesting mixing projects. So here's one interesting project that's called ZeroLink, and this is not the newest slide. Actually, I just updated a slide. Okay, so the very simple idea, it started with CoinToeing, which is the very simple idea of mixing inputs and outputs from different users. So by looking at transaction, you're not totally sure. It's pretty much like shuffling a deck of cards. So you're not sure like who's getting what from whom. But the problem with this is the mixer could cheat. It could like steal your money, and then the mixer could also like keep log of its users. So like if there's a subpoena on the mixer, then like they could like everybody could be exposed. So an improvement of CoinToeing would be the Chaumian CoinToeing, which uses blank signature to hide the outputs. So essentially, effectively unlink outputs from inputs. So you would have a set of senders and receivers, but even the mixer itself couldn't correlate between the mixer and between the sender and receiver. You could try to build, so like if you're interested in building a mixing service, you could also try to integrate this into a wallet. And for the Bitcoin ecosystem, there's the Wasabi wallet, which has like really good privacy features and has built-in mixing that gather transactions from its network of users and try to provide privacy for everyone. So it's a pretty interesting technique. And on the application level, like if you want to write smart contract or if you want to work with EVM, then you can experiment with zero knowledge proof. So a very simple introduction to zero knowledge proofs. So suppose you want to show somebody that you know the factors to the number C, and C could be a very big number, so it's hard to figure out. And you want to show them that you know A and B without telling them what A and B are. So it sounds like an impossible problem, but you could actually use zero knowledge to do it. And so here's like a blog article you could read if you're interested in like the intuition behind this. And there's not much math behind it, just like simple examples that programmers can understand. And so we can like expand onto this. You could treat like zero knowledge as a black box. So here's the condition you want to prove. So there will be a prover that's trying to, the prover is the person that wants to show somebody that he knows the two factors without exposing what the factors are. So here's like, you can imagine there being a function like ZK factor prover, and then the prover will pass in like the factors A and B, and C would be like the final number. And this function would produce like two data. It's essentially like a hidden version of the number A and like, so this is the output of this function. Then the prover can pass this output to a verifier, and the verifier could be anyone. And so here's another function that takes like the number C, which is public. So like the goal is to show that somebody knows the factor of A and B, right? So C could be like a publicly known number, and then you pass in like the hidden number A and B that's generated by the prover. Then you run, essentially you simulate this calculation. So given the hidden input A and B, which is not known to the public, you can simulate this computation cryptographically, and it tells you that these hidden input is equivalent to A times B equals C. So that's a way to show that somebody knows the factors of this number without actually showing what the numbers are. And it turns out that you can simulate arbitrary computations with zero knowledge proofs. And the idea is you have like a program, they just compile this program into an equivalent arithmetic circuit. And this arithmetic circuit is just kind of like plus and minus, combine all these arithmetic computation. You can combine all these arithmetic operations into to simulate a computation, and to do that in a zero knowledge way. Okay, so that's like the background of the technology, and you can read more into it with on Medium. There's like the blog articles I shared. So here's some applications of using zero knowledge proofs. So here's like a zero knowledge mixer, and the idea is you could send like money into a contract, and then for each deposit you make into the contract, you create a proof that you send money into the contract. And the interesting thing is, like in the previous example, we showed how you could prove like A and B, like how like really simple conditions. But in fact, you could prove even more complicated things. Like you could say, I want to prove that this data hashes to this hash, but without exposing the data. So like you can do a zero knowledge SHA-256 proof, and then you can also show you can do like a zero knowledge Merkle proof. So like instead of a normal Merkle proof, you have a simulation of a Merkle proof, which is zero knowledge. So the mixer is based on the idea of there being a Merkle tree and only the root of the Merkle tree is in the contract. So you want to show that you want to provide a proof that your money is in the tree without showing where in the tree your money is. So this is the intuition behind a zero knowledge mixer, and you can read into that like on GitHub, and then there's a documentation about how this works. It's actually like you don't need to understand all the math behind like zero knowledge proofs. You can just treat zero knowledge proofs as like black box. And I'll show you like some tools you could use to build this sort of things. And then also there's zero knowledge CoinToeing. So you could like build a UTXO based currency in a smart contract, and then you can do like mixing with zero knowledge, and you can read more on that on zero day. So for example, you could prove that the sum of your inputs equals the sum of your outputs in a zero knowledge way. So doing this, you can hide the amounts that are transferred, and which is like sort of equivalent to how Mimblewimble is done. Like this is essentially like the key to Mimblewimble, but using a completely different underlying cryptography. And this particular project is a mixing based project. So they're throwing decoys into they're throwing decoys along with the real transfers, and you can prove in a zero knowledge way that two of those decoys are actual real transfers. Okay, and there's also like zero knowledge plasma, where you do computations on the sidechain, and then you could prove that the computations are properly calculated and there's no cheating going on the sidechain. And the benefit of this over normal plasma is everything is ensured by the underlying cryptography, and there's no dispute process that's possible with zero knowledge plasma. So this is like also the interesting technology experiment you could read more into. And here are some zero knowledge toolkits you could play around with. And there's the Circum language, which is like a high level DSL for generating zero knowledge circuits. You could write the conditions. So like on the previous slide, I showed like you're showing the equations A times B equals C. So you could express something like that in the Circum language, and that would be automatically compiled into a zero knowledge circuit. And you could generate proofs and verifiers. And you could also generate a solidity contract from your zero knowledge conditions. So like this is a very simple to use toolkit for generating zero knowledge applications. And of course, you want to build like say a UI or whatever. You could use Snark.js, which is sort of like a complement to the Circum language. Then there's also Socrates, which is another zero knowledge language you could use to build zero knowledge applications. But of course, with zero knowledge cryptography, you need to have a trusted setup, and there's really no easy way to do this. So it's just like whatever. Just okay, and there are the smart contract ecosystem. There are some bigger zero decay snarks experiments, and there's like SiC, which is UTXO based, and and there's also Tether, which is completely different. It's account based, and it's essentially encrypting the data on an account, but it's more complicated and more expensive to use. Okay, and here's another like completely different approach to privacy. It's like instead of encrypting or obscuring your data, you just say, I'm not going to put my data on a public blockchain. I'm just gonna keep it private between me and the person I'm interacting with. So this is the idea of opening a state channel between you and your counterparty. And this is quite an interesting idea. So like the insight here is you you deposit some money on the smart contract, but all the logic and all the rules governing this money is actually, it doesn't have to be online. It's just something that's agreed between you and your counterparty. So suppose you and your counterparty follow the rules of the game, then there's really no reason and most players play according to the rules, then they just finish the game and they close the channel without actually saying what game they're playing. And the idea here is, if disputes should arise, the rules need to be made known. So the rules could be arbitrated by the smart contract. And it turns out you could build a contract where you say the arbitrator will be deployed on this specific address without actually deploying that contract. And that contract will only be deployed when there's dispute. So this is a way to hide the rules the participants are following by not deploying the rules. And it's only deployed when there are disputes. So that's just like keeping everything sort of generic, so people don't really know what games you're playing. Yeah, and here finally, like, so I just gave a quick overview of all the ideas that I know are out there, and there's some if anything that's interesting to you, you could just like click into the link and read more about it, and to see if there's anything you want to build. And here are some quantum coding tools. Like there's the coding manual, which gives you an overview of how to run quantum and how to interact with the quantum blockchain. And there's a smart contract JavaScript library, like Quantum.js. You can also like click on the link to look into it. And then, like, of course, like the quantum platform is more or less compatible with Ethereum, but not quite. So we built this Ethereum quantum bridge to make the compatibility better. So there are some like popular smart contract tools like Truffle that works on Ethereum. You can like use it on quantum as well by using this compatibility bridge. Yeah, I think that's all I have. That's the end of my presentation. Okay, thanks.
Thank you, Howard. Next, Alex is going to give us some advice about the privacy direction and also references and tools. And let's give the mic to Alex.
Yes, let me show you what we have from the Beam side. To complement the great presentation from Howard, I will show you the building blocks that you can learn and to use in building your hackathon applications from Beam. I will share my screen now, and I will show you what we have in this department. Everyone can see my screen? Yeah? Okay, so in the Beam repository, you can see the Beam project, and it's implemented in C++, very similar to Bitcoin. So inside, you can find a lot of basic building blocks that you can use for the cryptography and for a lot of mechanisms that are very useful in implementing privacy solutions. So inside the core folder, as you can see, there are a lot of specific implementations of the basic ECC, basic elliptic curve cryptography, the bulletproofs, the fly client idea, which is a very interesting way of sampling the blockchain and being able to verify it without downloading the entire block header history. Our implementation of the Lightning Network idea, which we call Laserbeam, it works very similar. There are some nuances in the implementation, but it allows you to create a funded channel and then have instant payments with zero cost and zero time confirmations between the wallets. the implementation of the Merkle trees in C++, and all the additional building blocks that are very, very useful to create solutions if you are choosing to do that in C++. Now, the bad news is that this code is a little bit difficult to understand at first, but we will provide all the support from our developers for everyone who wants to use this code. And there is some documentation available. I will show it in a minute. But the good news is that we have a lot of additional projects in many different technologies that you can also use, and I will show you what I mean. So of course, we have Android wallet and iOS wallet. So if you want to build your solutions by using and creating iOS or Android applications in your projects, you can use this code as well. We have a very interesting integration with the Trezor hardware wallet. So if you're into like more low-level C level stuff, you can use these projects because we have ported all the basic cryptography into C, and you can use that as well. Everything here is open source, what I'm showing. Of course, we have some JavaScript, and we have some projects that integrate decentralized and centralized concepts. Like, for example, we have a project called Beam Anywhere that allows you to pass messages using our SBBS system. It's a system for communication between wallets, for example, between your mobile wallet and some centralized service, and create these combinations of encrypted and secure and private but semi-centralized solutions. We have this project called Wallet Manager, which is implemented in Python. If you are into Python development, it's basically sort of web wallet, which works with our wallet API. And I will show you in a minute where all the documentation could be found. So as you can see, we have a lot of different building blocks built in a lot of different technologies. So I think there will be something for everyone who wants to build a solution in almost any technology that you can think of, and use these building blocks in your project to create this combination. And in a moment, I will also explain exactly what kind of ideas we had in mind. So inside the BIM project, there is a wiki right here, which has all the technical documentation, which explains how these things are working on the inside, starting with the cryptographic primitives, the Merkle trees, the core transaction elements, blocks, how the system state is formed, how mining works, how the secure bulletin board system that I just mentioned works, and all the other details are explained in here in the wiki. For the ways how to run BIM blockchain, you can go to the documentation .beam.mw, which explains the user side of things, and it's more suitable for users. And for the last part, I would like to go over these themes that we have for the hackathon, and I would like to share a few thoughts of how these things could actually work and what you can build using these tools from BIM that I have just presented. So obviously, the most obvious theme is the integration of Mimblewimble into Qtum blockchain, and it's, I think, very challenging topic, but it's also very interesting. It basically means replacing or somehow adapting the basic transaction and changing its structure a little bit to allow for these different UTXO representations. The privacy token theme is actually very interesting because in BIM today, we have this ability to create new tokens on top of the BIM blockchain. It's not enabled in the production version, but you can easily create an independent testnet that allows this. And the way it works is basically by adding additional generators to these structure of the Pedersen commitment that I have described. And instead of having BIM, as we have today with a specific generator, we can create new generators and encode new types of tokens on top of the same blockchain. This is an idea that we are going, obviously, to exploit ourselves in the future. But for this hackathon, I think it can create many very, very interesting possibilities of creating sort of stable coins that combine smart contracts on Qtum with this ability to issue assets on BIM, or maybe even some kind of bridges between tokens or contracts from Qtum into BIM and backwards. It's a very interesting topic that I would be glad to discuss with any anyone who wishes to go into this direction. So there is also a privacy smart contract, and in this specific case, I think the better technologies that apply here are the ones that Howard mentioned, such as Tether, which is very interesting development, and SiC. But Tether definitely, I think, something that you should look into. So privacy atomic swap, we have already implemented in Beam inside the same code base that you just saw. The master branch just basically contains everything. Atomic swaps with coins like Litecoin and Bitcoin, and since Qtum originated from Bitcoin, I think it can be easily implemented. And of course, there are several ways of doing this. One of them is using the hash and time lock constructs, but also do it differently and have more privacy in these swaps. Also very interesting topic that you have already all the building blocks inside Beam that you can readily use in C++, but it's very, very interesting. Privacy stablecoin, as I just mentioned, depending on whether you want to build it with algorithmic stablecoin or maybe some collateral that you manage manually. Privacy lightning. So as I mentioned, we already have a really working implementation of this concept that we call Laserbeam that allows you to create a direct channel between two wallets. But the real change here is to implement the routing part. And here also, I think there are a lot of things that can be done by interacting between the two blockchains of Beam and Qtum. And the last one is the privacy wallet integration. Of course, there is infinite amount of development that can be done on different wallet implementations, integrating the currencies together, integrating some interactions with smart contracts, which basically, for example, build on top of the SBBS as the messaging mechanism, which is it can be easily extended to include additional message types and transfer additional information. I think that this is like one of their very interesting in terms of usability and creating new scenarios of interaction between the blockchains. I think there is a lot of potential ideas here. So this is my introduction to the tools. And as I mentioned, we will be here to support all projects in any way necessary.
Well, thank you, Alex, for giving us a walkthrough of the tools and environment and giving us different ideas participants can work on. I think now we have a clear idea of all the development tools and different directions. For the participants, if you have any questions, please comment in the chat. And in the meanwhile, I would like just to thank everyone for joining us. And please join our Discord sub-channel if you haven't. You can find the link on our website. We will do all the announcements follow-up in our Discord channel and also on our website. We'll also have team members both from Qtum and Beam to answer questions in the Discord channel, both technical and general questions. Okay, so there's a question. Is there any way to connect to Beam's blockchain via Node.js? I think that's a question to Alex.
Yes. Yes, there are several ways to do that. The simplest one would be to do it through our API wallet, which can be easily extended, or if you can use the existing API, which is documented, and to create Node.js project around it. I believe that the good example is the Mirror Wallet project, which is right now available in our repository. You can take a look at it and use it as an example of doing exactly that.
Okay. Is there any other questions? We will share the video recording of this webinar on both YouTube and our Hackathon website. Our next webinar will be on July 29th. Please stay tuned. If there is any other question, I think we'll see you next time. Thank you everyone for joining us. Okay.
Thank you.
Thank you.